So I'm John Leung, Principal Engineer at Intel. I am also on the incubation committee of OCP, and I oversee the hardware management project. And with me is Han Wang from INSPER. He's a senior architect there. So this is the overview. I went through a couple of these slides yesterday to get, as a teaser for people to come to this particular meeting. But I want to go over the overall motivation and goals for OpenRMC, the logistics in the meetings, and then a review of the status of what we've gotten so far, where we are with the interfaces and the requirements, and then what contributions we received so far. And then we'll kind of end with the RMC for OpenEdge. So as a matter of fact, in the previous meeting just prior to lunch at the OpenEdge, Nokia stood up and was talking about their RMC. So it was a good segue. Okay, so the specific goals of OpenRMC is to go specify a rack management controller, both its service interfaces, its northbound interface, which is exposed to some client which wants to manage multiple systems and racks in a rack, and then a southbound interface set of requirements. So the requirements for a southbound interface are not as specific as the northbound. So for a northbound interface, you might want to be able to reboot the entire rack and all the systems in it, and that would translate into a southbound requirement of I need to be able to reboot your server. So whether it's via Redfish or through something else, that's still an implementation decision. But the topside northbound interface of the rack management controller will be Redfish. And then the second was to deliver rack management implementation. So once you define the top northbound interface and the southbound requirements, you can now go actually do an implementation to see how this will work. And for that, we've asked for contributions from the community, and then eventually it will be put on the Open Compute GitHub for those who have building RMCs to actually use the RMC firmware. And then, so on RMC, both have a software aspect and a hardware aspect of it. So we left the hardware aspects of it outside the subproject, and we said these are owned by their individual platform groups projects. So we'll talk about that in a few seconds. Okay. So what's the motivation for this? So OCP has two things trying to drive it. A couple of years ago, it had a series of presentations which said open software, we have it, open hardware, that's what OCP is trying to get to, and then open firmware. And open firmware was necessary because in the current OCP model, vendors submit designs for, let's say, a server, all the hardware CAD drawings, everything, and that becomes OCP approved. And then once it's approved, then vendors can actually pick up that design and build them and come back to OCP and say, you posted the design, we built to the design, here's our product, here's all the CAD drawings for our product. We'd like the OCP accepted or OCP inspired monikers on it. And that was fine, but currently when you submit a design, you can provide all the hardware specifications, but as far as firmware is concerned, which every piece of hardware needs, you can just provide your binary blob of firmware. So that's great for the design. The implementer has a problem because he's going to build the hardware, and then all he's going to see is your little firmware blob to drop in there, and he doesn't know what's in it. And so it's very it's problematic, and a lot of vendors have to go back to scratch and go build the firmware themselves because they need to know what goes into it. So open firmware was something we saw was very necessary for OCP to get this thing truly open as a piece of hardware. So if you look at the system, I've enumerated two of the larger items, which is one BIOS, or the boot PROM, which OCP is trying to open source via the OSF project. Most of the presentations this morning was regarding OSF, and that was how you could build a similar design with BIOS and have BIOS part of reference and open source implementation. So some vendor can go and say, fine, I'll here's your image that you submitted with your design. I don't like the specific string in it. I want to go modify it. You point to the source. He can go to the source, modify it, and build his own BIOS. Okay. So that's BIOS. BMC is the other large piece of firmware, and that provides manageability for the platform. And so currently the source code for BMC is one for OpenBMC. There's a lot of proprietary implementations. OpenBMC is now governed by the Linux Foundation in March of last year. I think we announced that it had finally been agreed upon. So the problem with OpenBMC was it was released by Facebook 4 or 5 years ago. And since that time, it had splintered. And by the time OCP looked at it and we were trying to put a Redfish interface on top of it, it had splintered into 6 different repositories. And it took 6 months, 9 months to get all the principles back together again and say, we should really get back to one source code for OpenBMC. And that was finally done after a lot of work. And we found an independent party called Linux Foundation, which willing to accept it and use its governance model. So, so in the diagram on the right, we have BIOS, we have BMC firmware. So the next place where we saw firmware was at the rack manager. And Bill Carter, the CTO, came to me and said, John, I don't want this to happen again. I think OCP should be a first mover into this space and release a reference repository of code and try to prevent the industry from splintering apart and having different repositories. Okay, so hence I was chartered November of last year to basically define the interfaces and get an implementation out there so people could start rallying behind it. Okay, any questions? So with on the top right, with the rack managers, there's the software, and then there is the hardware. So RMC Hardware basically is there's lots of places. So if you look at systems today, the RMC can reside in at least 3 major places. One is on the power shelf, because it's usually a small microcontroller. Various people have put in various places, and these are all 3 instantiations that currently already exist in the industry. The other exists on the switch. There's usually 1 per rack, so they stuck it on the switch. And then the last is they actually have a fully standalone system called RMC, which basically runs firmware. And so it's not attached to anything. So who manages the hardware side of this, of RMCs, is that we left it up to each individual project group. So if it comes on a power shelf, it goes to Rack and Power. They can go accept the design and the implementations thereof. If it's on a switch, the networking guys can do it. And if it's a standalone system, the server guys can accept the design and handle it. Just an hour ago, before lunch, OpenEdge came in with their RMC. So who's going to deal with that? Telco is, right? Because it's coming out of a subgroup of telco. So this splintering of the hardware and software again is a good thing, because I don't have to deal with any of the hardware. I just have to deal with the software instantiation that will be instantiated in any piece of hardware. Okay. And with this, I'll leave it to Han. He'll go over a couple of slides on logistics and how far we've gotten.
Thank you.
Just talk.
So thank you, John. So
It'll get.
okay, yeah. So I will give some updates about.
Is this not working?
Hello.
She left the room.
Can you switch? Yeah. Hello? Yeah, okay, thank you. So I'm gonna give some update about the OpenRMC subproject status and the future plan. Also talking about some potential target hardware platform John just mentioned about. So overall, so OpenRMC is a subproject of the OCP hardware management project. So right now, John and I are sitting as a project lead. So we have a OCP wiki website, so you can go there. So lots of resources over there, all the meeting notes, and also the working documents and a spec. So we also have a bi-weekly meeting. So it will by every other Tuesday and 9 a.m. Pacific time. So if you have any topic you want to bring up feedback, we can set up an agenda to talk in the meeting. So also we have a mail list. So you want to know the latest updates about this project, you can let us know and we can include into the mail distribution. So the major participation company like ARM, Microsoft, Facebook, Inspire, Nokia, Intel, etc. Yeah, so the OpenRMC project, as John talked about, so we kick this off from last November. So we have make some couple of progress. So we have 4 companies which already share their architecture interfaces. So those are Facebook, Intel, Inspire, and Microsoft. So from draft perspective, so we have both NASPAN API spec, also the Southbound API spec. So right now we just have the version 0.4 for the NASPAN API. We define all the service collection and profile. We're still collecting internal feedback. So regarding the RMC source code contribution, so we have three companies right now from the beginning of this year contribute all their source code, and we do very detailed architecture review and a detailed code walkthrough. So those are Microsoft, Inspire, and Intel. So we have a OCP GitHub, so we have the individual repository for individual contribution. So it's on the GitHub, the Open Compute Project Rec Manager. So you can go to the GitHub website, go to OpenRMC folder, you can look at the individual source code contribution. So at a high level, about the 3 contribution is summarized in this table. So basically, Microsoft Inspire are using an OpenBMC base. So all the source code are written in C++, and the processor used is AST2500, so it's a wide used. So OpenRMC project, the goal is, so we want architecture and implement open source rec manager controller. So we don't want just put binary firmware image. Instead, we want to replace with all the source code. So we have, as we said, we have a GitHub OCP website location for all the RMC contribution. Also in the future and in further OCPRMC contribution, you can reference individual source repository. So from OpenRMC perspective, all the OpenRMC source should confine to the OpenRMC NASPAN API. So the plan for NASPAN API is, right now we have 0.4 version. So we're gonna have, in the beginning of October, we're gonna release to the public review to drive to the version 1.0. And at the beginning of November, we will get a final approval on the profiles, and we will release the spec and all the profile list in November. So also talking about a potential target hardware platform. So this is from Nokia Airframe. So this is originally is for the OpenEdge chassis. So we don't really go to very detail about the chassis. So this one, I remember it's just got approval as OCP Inspire. So they already decided to contribute the RMC part to the OpenRMC as a test vehicle or implementation target platform. So there are 3 major components in the front architecture. So they have the PSU and they have compute slot and also has a chassis manager controller. So the interconnection is via the PDB board and the backplane. So we will more look at the chassis management because they are targeting use this as a RMC for the OpenRMC platform. So this is a close look at of the airframe, the RMC. So inside the chassis, they are doing control the PSU management. So basically is control and supervise all the PSU. So also, of course, they can access all the sensor data. So the control process chip is using the ST2500. So the protocol they support RESTful API, the Redfish, also Sports Mesh, also Legacy IPMI, also SNMP. So one key feature about this RMC is they have an internal switch, management switch. So this allows they have an internal 1G management network to each individual Slack node, also the PSU. So outside for the external management network, they offer the 1G RG45 to external management network. They also have two 10 gig SFP plus to connect to external connection. Also can allow the changing multiple chassis. Yeah. So that's the roughly overview of the airframe RMC. So I think pretty much for me. So yeah. Go back to John. Thank you.
So this is all in keeping with the fact that in order to get an RMC working, I need hardware, I need software. We've got 3 software contributions, I need a hardware contribution, so I can actually close the loop between getting a piece of OpenRMC software firmware running on an RMC that's also an OCP platform. Okay, so I mentioned that the RMC has a northbound interface of Redfish, and this is so one of the reasons is that OCP has adopted Redfish as the future manageability interface for all its platforms, and for a number of reasons, and this being one of them. So one is that the DMTF has written a bunch of models, and other vendors are building additional models, other standards bodies. SNIA is doing storage. The Green Grid is doing DSIM, which is all the facilities equipment inside the data center, the cracks, the PDU units. And so part of that is the fact that Redfish all it does is it reduces manageability to a URI and a JSON packet. And so most of the information is detailed in the schema that describes exactly what's in this JSON packet. So that's where Redfish is just expanded. But most people look at that and say, well, great, Redfish describes a lot of things. Do I have to implement all of it? And the answer is no. We need a prescriptive power to tell you what subset of Redfish you actually care about. So within the DMTF, we've defined, the hardware project has defined a baseline set of resources and properties that need to be implemented on all OCP platforms for manageability. And then, so we've just built on top of that. So we said for RMC, we're going to use the same tool chain, because we can now go use Redfish, define the resources and properties that need to exist, and then we can write it all into a profile. Profile is a JSON formatted file, yet another JSON formatted file. But in this particular case, it is read by a validator. And the validator basically reads the input profile and then auto-generates all the tests, and then tests a conformant implementation. So the backend is kind of taken care of. You don't have to go off and go write a bunch of tests for it. It's part of the fact that the OCP has written a profile, and all the backend is just kind of taken care of. So for as soon as the northbound interface is done, and we're doing this concurrently, the OpenRMC profile will also be released at the same time in JSON. So if there's any implementations that come out there, we can automatically read it into a Redfish interop validator and then test against it to make sure you have all the properties and all the resources as required by specification. So Normally, in standard, this takes a while to get done. By using this tool chain, we just kind of get it automatically. So the interop validator is actually one of an entire suite of tests that on Redfish, and all these tests are open source on the DMTF GitHub. So one is, so I'm not going to name them all, but most of them check the actual implementation of the interface itself, the communication channel, and it's only the validator that tests the actual resources and properties that need to exist. Oops. Yeah, so status against goals. I think that was it. Yeah, status against goals. So the status was we want to specify rack management controller server interfaces. So when I did the slide a month and a half ago, we were at .3. We've gone to .4. We're kind of in a rapid process. So we went off and did this review of OpenEdge for a while, and then we decided we really need to finish out this specification, because the specification is what's going to drive the backend validation. It's going to drive everyone forward and start looking at this. So we expect to close this by the end of this year and go quite, and then kind of get IC to approve it in the first quarter of next year. And I think once we get that out, then people will start looking at it and say, yeah, if this is all I need to implement, then I've got a hard target to go point to. Deliver a rack management implementation. So out of this, we have 3 RMC code repositories, which are part of the GitHub. They're under 3 contrib folders. There was nothing under the RMC folder itself because none of them have been selected. And so we're in the process of figuring out whether we can get there in time. We'll definitely have the interfaces specified. We will not have the implementation for a while. And then last is OCP compliant hardware, right? So the expectation is contribution to of the profile, and then the hardware itself. So as I mentioned earlier, OpenEdge is in the process of donating their RMC. And there's another RMC out there on the Experience Lab, and they're also thinking about donating their RMC, so we may have 2 hardware platforms to go support this firmware. Yeah, that's that. And then so the call to action is join the OpenRMC discussion. Everything has been posted. I've tried to organize everything so you know what we're working on versus what is being contributed by each of the other companies. The OpenRMC meetings are meeting twice a month. So most projects meet once a month. We've been on a fairly rapid pace of meeting twice a month to get stuff done. And then contribute to the RMC source and profile. So I'm fairly open on getting this done. So the rack manager source is out there. So all the rack manager project code is out under Rack Manager, and then the OCP profiles. There's a dedicated GitHub repository for all the profiles, whether they be the baseline, the server, the storage profile should come soon. The OpenRMC profile is already out there. And so we can modify it using GitHub technology as opposed to the way I've seen it done before. Okay? With that, are there any questions? Yes?
Thank you for this clear presentation. You've presented three deployment possibilities. All possibilities were embedded. Do you think it's possible to deploy OpenRMC in a regular node?
Oh, absolutely. As a matter of fact, the third one, which is a standalone system, is a regular node.
Okay.
It's basically a server attached to a switch.
Okay. And another question, is it possible to manage multiple racks with one OpenRMC instance, or is it only dedicated to one rack?
My design target is one rack. So I can see it being extended quite easily to manage multiple racks or entire rows of racks. But that's not the design point.
Yeah, technically, I don't see any technical hurdle you can scale out to multiple racks. Yeah. So right now, ideally, it's still for a single rack.
Thank you.
Yeah.
So one comment on looking at the source, it seems a little fragmented in terms of Inspur and Microsoft. Are you all looking at maybe kind of cleaning up and producing a source tree with just kind of a common source code base? I'm just looking at the tree right now. I just noticed a lot of this like fork at the top level between the Microsoft and Inspur contributions.
Do you want me to answer that?
Yeah.
Yeah. So that's why the second step of trying to get to a single source code may be problematic. So right now we're looking at each of them should at least point to OpenBMC, right? And then just specify the incremental files they want to layer on top of OpenBMC to go build their source.
And I kind of missed that during
Yeah.
your talk. Okay, thanks. Let's thank our speakers.
Thank you.
Okay. Thank you.